Hello, STEM Nation. Jeff here, and welcome to episode number 4 of STEM on Fire, where we interview practicing professionals in the area of science, technology, engineering, and math. Let's start by thanking our sponsor, Audible, who's offering a free audiobook at stemonfirebook.com. You can go to stemonfirebook.com, get your free audiobook, and if you're looking for a good book to listen to, I would highly recommend The 7 Habits of Highly Effective People by Stephen Covey. Let's get fired up with our guest, Joe, and I hope our chat today will help ignite your passion towards a STEM career. Joe Pfaff received his Bachelor of Science degree in Electrical Engineering in 1994 from Marquette University and his Master's of Business Administration from Marquette University in 2004. Joe is currently the Vice President of Off-Highway Engineering at Husco International and has been at Husco for 21 years. Welcome to the show, Joe. Take a moment to fill in any gaps and share a bit of your personal life.
Yeah, thanks, Jeff. Happy to be here. If I go back to when I was a kid, I have always loved and been just fascinated by construction equipment and making things go. I was a big, loved to play with Legos and do computer programs as a kid. And I got into electronics in college. And then as fate would have it, I worked on engines for a while at Briggs & Stratton and then started working at Husco about 20 years ago. And I've joked many times that I basically have the dream job that every 10-year-old wants. I get to play with these big pieces of construction equipment and advance them to doing things that we need them to do in the 21st century. So I've had a lot of fun.
Excellent. Hey, thanks, Joe, for filling that in. So you've got a bachelor's in electrical engineering, and then you also have a master's in business administration, otherwise known as an MBA. So for the electrical engineers out there, can you give some examples of career opportunities, and then we'll delve into your area of expertise?
Yeah, sure. So electrical engineering, electronics and software are in just about every product that we have today, right? I mean, when I went to school 20-some years ago, that was really just beginning. But today, it's hard to find a physical product that doesn't include electronics and software. A lot of people call that the Industrial Revolution 4.0, really the digital transformation into all of our products. So I would say that it's less common today for people that get an electronics degree to stay exclusively in electronics. That often today, electronics engineers are working with mechanical engineers or chemical engineers or aerospace engineers and integrating electronics into all of the products that we have. And I think that's happening to all the fields, but maybe even more impacting electrical engineering and electronics, because they're so ubiquitous in so many of the products we have today. So, and I think that's one of the brightest features of electrical and electronics engineering is just so many directions that you can take your career today.
Yeah, I think the electrical and the mechanical, there's a lot of folks that like mechanical engineering. And in my opinion, I think if you're a mechanical engineer, you probably need a little bit of electrical knowledge and maybe even some software background. And at Husco, since it's kind of heavy equipment, I'll say, do you think that a mechanical engineer that might be thinking of working on motors should have some background in electrical and maybe a little bit of software background as well?
Absolutely. So ironically, some of our best hydraulic and mechanical engineers got a degree in electrical engineering, and some of our best software engineers are people that have a mechanical engineering degree but always had an interest in software and developing it. So I believe that having multi-domain fluency, so in other words, an electronics engineer or electrical person being able to understand the work of a mechanical engineer or a controls engineer is really critical, and vice versa. People with a mechanical engineering background or a control and systems background being able to be conversant with the other domains in engineering. People that can cross over those domains and be really fluent in all of the technical challenges and opportunities, kind of a Renaissance engineer. Those are the ones that really have really fulfilling careers and are really valued in the commercial area.
Yeah, I agree with that. I think the kind of that multidisciplinary capability where you're not just pigeonholed or just deep focused into one of the engineering disciplines, I think that's important to have some diverse background. So let's get into your specific area of expertise, Joe. I know you're the VP of engineering, so you might have a different perspective, probably not doing day-to-day engineering design, but if you could give us your area of expertise, that would be great.
Sure. So like I said, I came from a background in electronics and software. So my expertise, what I'm good at is abstracting a problem. Electrical engineering is an abstract problem because you never see the electrons, you never see the voltage, you never see the current flow. So at its core, electrical engineering is an abstract domain. And I have taken that through my career and applied that kind of abstraction to the hydraulics domain and the mechanical domain. And so what I'm really good at is understanding a problem, abstracting it, being able to see it through the lenses of all the different domains of engineering, and then working with the team, creating some creative solutions, which are agnostic to the domain, right? So whichever solution, whether the solution can be found in electrical engineering or software or mechanical or controls, being able to understand all those things so that we have the best solution as a product. And so that ability to abstract things, to think of them in their simplest forms, and then the ability to communicate those in a visualization are some of the things that I'm really good at. Basically taking in the problem, putting it in a simpler building blocks, working with a team to figure out a solution, and then communicating that broadly in a way that's digestible for everyone internal to our organization and for our customers. That's kind of my job. That's what I'm good at today.
Okay, so you went for a master's of business administration, an MBA versus a master's in engineering. Can you explain why you chose to go the MBA route versus a master's of engineering?
Yeah, happy to. So one of the reasons is I'm not great at math. That sounds like a really terrible cop-out, but there's some truth to it. I'm an algebra guy. I mean, you get into some of the more advanced mathematics that are required in a master's of engineering. And to be honest, I was worried about it. Now, in retrospect, I would have done fine. But the other part was I wanted to learn more about the business. I wanted to understand business is just like an engineering problem. There's inputs, there's constraints, and then you have to mix those together for a solution. And I didn't feel completely fulfilled that I was maximizing kind of my potential in my career without understanding those dimensions in the same way that I described electrical engineering, mechanical engineering, and controls engineering. I didn't have the business domain understanding to mix all of those together. So that's why I chose doing an MBA. At the time, they did not offer combination degrees where you could have a technical and commercial coursework combined into like a master's of engineering curriculum, which is offered today. If that was available, I probably would have done that. But at the time, it was somewhat of a more digital choice. You could either get a technical master's degree or a MBA. So that's why I did it. But if one of those cross degrees were available at the time, that's probably what I would have chosen.
Yeah. Hey, thanks for that, Joe. Yeah, STEM Nation, if you're thinking you like the business side of things and you also like the technical side, right? Go get an engineering degree. And then you can also go get your master's in business, or you can do a kind of a hybrid degree like Joe's explaining. So thanks for that, Joe. So, Joe, what is one thing that has you really fired up about electrical engineering, and where do you see it headed?
Okay, I have to give a little bit of background. So
sure.
Today, there's the integration of a lot of electronics and software into numerous products, and it's disrupting whole industries, right? The largest taxi cab company in the world owns no taxis, right? And they're called Uber.
Yep, you got it.
The largest music distributor called Apple has no stores, right? So there's, and I could go on and on. The largest the largest company that's providing rooms for lodging owns no hotels, right, called Airbnb. So all of these businesses are being transformed by different business models that are taking advantage of the digital domain. And as we look at what's going on with Tesla or some of these other things, we can envision now a future where what we do with assets, how we take advantage of them, is going to change really fundamentally. So as we look at our company and our customers and our market space, how electronics and digitization of those products impacts them is really transformative, right? I mean, if we think of what they're going to look like in 10 or 15 years, they could look really, really different. And that's on the heels of about 50 or 60 years worth of, by and large, really good, but somewhat incremental progress, right? You could look at what a backhoe or an excavator or a bulldozer looked like 20 or 30 years ago, and you would instantly recognize it. Some of the products that I can imagine coming in 10 or 15 years would be completely different form, and that form would be enabled by the digitization of that machine. And so that upheaval, that transformation that's going to happen as part of the electronics and the software that will be added to these machines and their capabilities, that's really exciting. And it's really exciting to be part of it, to be a player in that market. And so for me, that's really exciting. And to be, and then the other one is really our contribution, Husco, where I work, and our discipline of hydraulics and the ability for it to save energy. Energy is one of our most limited resources, and so the ability to contribute to a more efficient world is also a big motivator for me.
Yeah, that's some great insight, Joe. Now, in the driving world, in the cars, right, we've got autonomous vehicles coming down the pipe, right, where you're not going to be driving the vehicle. Do you see that also happening in the heavy equipment, where you typically have a driver driving the excavator or the backhoe? Do you see that being autonomous in the future?
I do. Now, when I say I do, I don't think all of them will be, though. Okay, so today you can find autonomous big mining trucks in large mines. Today, when a bulldozer driver is pushing earth while they're building, let's say, a golf course, all he's doing is driving. The blade of the bulldozer is actually being controlled by GPS. And so it's in a way machining the earth in the same way a cutting tool would if you were machining something. So some of the functions of the machines are already being automated, kind of in a similar way that adaptive cruise control will automatically control your car speed on a highway. And so those incremental autonomy functions will increase in their scope and capability and cost, and then eventually it will enable the entire machine to be automated, probably at first in a leader-follower type mode, where you'd have one bulldozer with a man in it who's leading a train of multiple bulldozers. But eventually one can imagine pretty easily that all of those machines could be automated. Whether that happens in 5, 10, or 15 years is really difficult to say. But is the trend there? Are the capabilities there? Is there a business model for it? I see there being one.
Yeah, and I think that's why the engineering positions, both mechanical, electrical, software, all three of those disciplines are absolutely going to be involved, as well as the civil engineers that are going to be, I would say, maybe determining how these pieces of equipment are going to be used for, developing roads and whatnot. So the future is bright for all these engineering disciplines, which that has me fired up as well. Joe, we're going to change gears here a little bit, and we're going to go to an aha moment you've had, something that might help our STEM nation. Can you take us to a moment in time of an incredible aha moment you've had at work or your personal life, and tell us the story and how you turn that aha moment into success?
Sure. Aha moments are interesting. They're normally on the tail of a lot of hard work and disappointment.
Yes.
I will say that one common ingredient that I talk a lot about with the people I work with is the importance of knowledge, right? That to really create novel, high-value solutions, to have those aha moments requires a really deep knowledge base. Normally, really transformative ideas, really, really valuable ideas, come after that investment in knowledge. And so the aha moment is really special, but it comes in the tail end of a lot of work. I have two, though, two aha moments that have been kind of fun in my career. One was we had a set of requirements from a customer on everything they wanted this machine to do, and they were completely unreasonable. I mean, there was no way that you could do everything this customer wanted to do. And so a group of us got together in a room and we said, all right, let's quit complaining about the fact that this is so difficult, and let's actually try to figure out how to do it. And so we did. So over the series of weeks, we tore down these requirements that the customer had and generated ideas and tore them up, And then finally, the 12th idea came, and all of us looked at it, and within moments, we knew it was the right way to do it. And it was one of the most special experiences in my career because collectively, we had kind of joined in that thought modeling. And then when we found the solution together, we all recognized the perfection of it. And it was one of the richest kind of joint experiences I've had in my professional careers, because it wasn't just an aha moment for me. It was an aha moment for this group of people. And that was really special to share, because otherwise it's a little bit selfish, quite honestly. One of the other aha moments that I'll share is a similar situation with a lot of hard work leading up to a need for a customer. And we happened to be speaking to the customer. I was actually presenting, so I'm standing in front of 12 people. And a guy from the customer asked me a question. And as he asks it, the answer comes to me in that aha moment. And I ask for a quick coffee break so that I can go and write it down and change the presentation and present to him the solution to sell him in the same meeting, to turn it around within like 5 or 10 minutes and try to make it a sale so that we can actually get some new business. So those are two for me. But I think the important thing is that knowledge is the key, right? The more you understand a problem, the more constraints you understand, the more elegant the solution. And that makes the aha moments that much more special, because you've invested so much before the aha moment.
Yeah, those are awesome, Joe. I really like the one where you get the requirements from the customer. You know, you go, there's no way we can do it. The customer's unreasonable. And then you decide, you know what, let's just stop complaining about it and just go make it happen, right? So you come up with some ideas and they're bad. And all of a sudden, boom, you get the right solution. You're like, wow, that was awesome. And if somebody isn't pushing you, like your customer, you know, you probably would have never came up with those ideas. So that's some great insight, Joe. Appreciate that. All right, Joe, hey, we're going to transition here into college, you know, kind of way back when for kind of you and me. But STEM Nation, you know, they're juniors and seniors in high school heading off to college. And these STEM curriculums, they can be rather challenging. Like you said, you weren't the best at math. And, you know, I didn't have calculus in high school, so I started out at the low level. And they were challenging, and I studied a lot. So if you could go back in time, Joe, when you were 18, what would you tell yourself as you're heading off to college? Some things that you wish you knew back then, or even knew back then, that would help our STEMers launch into college successfully?
For me, the way I learn best is when I am introduced material in the classroom and I have a fundamental understanding of what's being discussed. And so in my young life, as in grade school and high school, and when I was working on my bike or playing with Legos, that was really helpful actually then to layer on top of that, or working on software as a kid, to layer on understanding when I went to college. And as a dad now, I have a daughter who is interested in learning how engines work. So we bought an old moped and we took it apart and we put it back together, and it didn't work. And so we did it again, and we did it again, and we did it again. And now we've done it 4 or 5 times and it's working. And now she understands how engines and transmissions and brakes work. And although that's not a career, it provides understanding in how things work. It gives you that fundamental kind of gut intuition about things that then you can layer on these more advanced topics that you're going to get into college. So my recommendation would be go out and explore. Take stuff apart, break stuff. Doesn't really matter whatever's interesting to you, whatever is going to keep you engaged, whatever is going to get you fired up. That's why you're a technical person, is your curiosity, right? So feed that curiosity and build it into a background structure, a skeleton, that when you get to college, you can add on to it, right? It'll be that much more meaningful if you've got some sort of frame of reference for all of the learning that you're going to get in college. And then the same once you're in college is really seek out other opportunities. Get involved with the Baja team or the flight team or the whatever, all these different clubs that you can get involved in and build things, right? Collaboratively. The more you do that, the bigger investment that you make into those foundational things, or foundational learnings, the more successful you'll be in onboarding the abstract concepts that you'll get through your school experience.
Joe, that's great advice. Joining these organizations within college, it helps you develop your people skills. I know that a lot of times engineers get pigeonholed into, no personality, and I don't agree with that. I think it's just a matter of time before those engineers blossom. And getting involved with like the Baja team, the flight team, there's even, I think Platteville has a snowmobile team where they go and work on sleds, which is kind of cool. So get involved and grow your skills and gain that knowledge like Joe was saying. I mean, Joe's a VP of engineering. He knows what he's looking for, when he's going to hire people. So take his advice and take it to heart and go run with it. So, Joe, you are the VP of engineering, so you're probably involved in some of the hiring processes. So what are some of the skills or attributes you think STEMers need to have to be successful when they transition from college into their careers?
Yeah, I'll give you an answer that's maybe a little bit not expected. I believe that college is a hurdle. It's a challenge. But in the end, what it takes to be a really good engineer is more so about your entire career learning, right? Your habits of learning, your habits of curiosity. And so what I'm most interested in when hiring someone is not their specific skills, how they did in calculus or how they did in statics and dynamics or computer science courses or electronics courses, but really looking for people that, one, have the attitude, effort, and capability to be lifelong learners. And those are three really important characteristics of your core, right? Attitude, effort, and capability. If you have all three of those, then that means that over your life, you will also continue to invest and develop your critical thinking, your communications, your collaboration, and your creativity. And then those four things, those four C's, build into specific skills that you'll have doing the job. But the job is always changing, right? Technology is always changing. The requirements are always changing. So it's not as much the specific skills in Pro-E or SolidWorks or whatever that really make the difference when you're looking at the time scales of careers. It's really those other core principles, right, of how you're wired, how you turn those into those four C's of capabilities, and then how you direct them to specific skills. Those are the really most important things that we look for, because then you can create a lot of value. We do not purely just transform an input into an output, right? Our value creation as engineers is doing the heady stuff, right? Using our brains to do the creative, critical thinking, and then collaborating with our teammates and communicating it to our peers and our customers. So being really good at that, those are the things that are really important for me when I'm looking to hire someone.
That's fantastic advice, Joe. I mean, attitude, that's not something you can teach. That's something that you have internally, and you have to have a great attitude. And that's going to come through on a job interview. If you have the right mindset, the right attitude, the lifelong learning capability, it doesn't matter if you got a C in a class here or maybe a C minus. But if you have the right attitude and you have that desire to learn and just drive forward, you will be successful. So don't worry about that, bad grade here and there. You can overcome that. So, Joe, we're going to transition into the lightning round. Are you ready?
You bet.
All right. What's the best piece of advice you've ever received?
Probably be humble. One of the things that happens in a technical field is that you get you become in love with your own ideas, right? Your conviction of the rightness of your perspective becomes really strong. And when you're working with a group of really smart people, they have their own convictions of their perspective being right. And the humility or being humble is really key so that you can open yourself to their perspectives, because the best solution is most likely neither of your ideas. The best solution is oftentimes a combination of those two or a completely different solution that is unlocked by debating and working with that other person. So humility, I think, is actually probably one of the best pieces of advice that I've gotten in my career, because it really opens the door to advancing toward a better solution and adding value to everyone around you.
Yeah, being humble, I think you live that with your aha moment of getting together with a group of folks. Is if everybody thought their idea was the best, you never would have came up with the best solution. So, Joe, what's a personal habit that contributes to your success?
It's the habit of lifelong learning, always putting yourself at the edge of what you feel comfortable with. In other words, we should always be pursuing things and doing things that make us a little nervous, that feel a little bit awkward to us. Because if we're doing that, then we know we're right at the edge of our capability. We cannot permit ourselves to become complacent, right? We have to be at the edge of our learning, because in a career, you will be working for 40 some years. And in your career, you're probably going to have 5 careers, actually, right? There's probably going to be 5 distinct chapters in what you're going to do. And so we always have to be preparing ourselves for that future. That's why it's rich. That's why it's fun. That's why it excites us from a creativity standpoint. But we always have to be investing in ourselves and at that edge of learning. So for me, I'm an avid reader. I seek out new experiences, both culturally, in business, in relationships, in talking to peers and how they do their businesses, but really just continuing to expand the experience base and expertise so that your worldview and your capabilities all get expanded throughout your career. So that habit of kind of always be seeking new, expanding skills and capabilities and knowledge, that's a habit that I have that I think has been good, and I evangelize about this internally at our company and with my peers and in my own family, that this is really how we not only have a fulfilling career, but to be honest with you, also I believe have fulfilling lives, right? We feel very secure in what we're doing, and we feel like we're fulfilling our potential. So for me, that's like a really core principle of how I try to live my life. And it crosses over between all those spaces of career and personal life and family.
Yeah, STEM Nation, get out of your comfort zone, live on the edge a little bit, feel uncomfortable about doing things. If you feel uncomfortable about doing it, you probably should go off and do it and develop those skills. What's one book you recommend?
I've read a lot of books that have influenced me. I would say one book that I'd recommend to everybody is called The Goal, Theory of Constraints. I read it actually as part of my MBA, but it's a great book on manufacturing and constraints in business. And it's kind of a fun book. Some other books, Innovator's Dilemma is a really good book by Christensen. Toyota Way, there's a lot of really good books on just organizational and lean associated with how Toyota runs their business. So those are 3.
So Joe, as we wrap up here, can you share a parting piece of guidance for STEM Nation, and then we'll say goodbye?
Yeah, really, I kind of said it before, but lean into it. Lean into what's interesting to you. And then wrap more knowledge and information about it and make a career out of it. As you build more and more knowledge, it unlocks more and more visibility to what your career and your life can hold for you. So invest in it. Consciously invest in it. Invest in yourself is something I say often to people, and there's so many ways to do it, but don't be complacent. Invest in it, and the payoff is compounding. Just like investing money, the same is true for yourself. You get those compounding benefits. So that would be my strongest feedback for everyone, is to make those investments.
There you have it from Joe. Invest in yourself. And with that, Joe, we'll say goodbye.
Thanks a lot, Jeff.
I hope you enjoyed our discussion today with Joe. Head on over to STEMonfire.com, subscribe to the email list to keep up with the latest happenings, and be sure to subscribe to the podcast on iTunes or Google Play. Tune in next week where we talk with Karen Bartleson, the president and CEO of IEEE, which is the Institute of Electrical and Electronic Engineers. Until next time, I hope this chat has helped ignite your passion